Okay, so this is for Anatomy and Physiology 1, Chapter 2, Part 3, starting with adaptive immunity. Um, we talked about these a little bit already, but to review, so adaptive immunity, what makes it different is it involves the antigen-antibody relationship. Remember, an antigen is an antibody generator, and an antigen is anything that can cause your immune system to respond um, to it. Adaptive immunity adapts to specifically, and it can make antibodies to bacteria, viruses, any foreign thing. Um, the reason why it's different from innate is it's specific and it provides long-term memory. So we can remember an antigen that's encountered before and elicit a stronger immune response. This just shows the interaction between the antibodies, that are like little Y-shaped things, and the antigens. They bind to each other, thus marking it for destruction. On top of the surface of antigens, there can be multiple epitopes, and every epitope can elicit or cause an immune response or the development of an antibody. The cells that link the innate and the adaptive immune system together are called antigen-presenting cells. And here in this picture, you can see it's usually a lot of times it's a phagocytic cell that ingests a bacteria. This is the non-specific innate response. But then what we'll do is present that antigen on its surface to another immune system cell, thus activating the adaptive immune system. The cells that usually act as antigen-presenting cells are macrophages, or a cell called a dendritic cell, which you can see right there. Okay, so this just shows how that antigen-presenting cell, how that process works. Antigen-presenting cell will put the antigen on its surface and present it, in this case, to a specific T lymphocyte called a helper T cell. Notice that it's inactive right now. Another name for a helper T cell is called a CD4 cell. Here's that process happening right here. So the purple represents the antigen. The antigen is being recognized, and they are communicating essentially, and that antigen-presenting cell is also releasing chemicals that co-stimulate that process, essentially to make it stronger, and now it becomes activated. Once that helper T cell is activated, see this arrow, what it can do, it can activate other lymphocytes called CD8 or cytotoxic T cells to do their job, and their job is to directly kill foreign invaders, or they can make more of themselves, or they can even activate B cells, which is another type of lymphocyte that makes antibodies. And T cells themselves, like I said, become more numerous. Yes, okay, moving on. So once activated, the B cells over here, B, and T cells represent the two arms or the two different types of adaptive immunity. It can either be antibody-mediated, another name for that is humoral, or cell-mediated immunity. This image here kind of shows how helper T cells are in the middle and they can activate either this response or this response, cell-mediated, antibody-mediated. Cell-mediated, think of cells directly doing the attacking in the immune response. So cell-mediated, essentially the cells are, immune cells themselves are doing the direct attacking. So it's mainly involving these cells called cytotoxic T cells. Those are the CD8 cells, and what they do is they will directly attack. They will find cells that are infected by foreign invaders with an antigen that is harmful to us, or like that is already in the cell, so intracellular pathogen, or they destroy cancer cells, okay? And in the process, in cell-mediated immunity, there's direct killing going on, okay? But also, suppressor cells are being produced, and memory T cells are being produced that remember that specific antigen. that the helper cells show them. The other type of immunity, pardon me, antibody mediated, is, think B cells, okay? So over here, cell mediated cytotoxic T, antibody mediated is B cells. So what happens when they're activated by the helper T cells? B cells can transform into antibody making plasma cells. So the B cells become a plasma cell that secretes antibodies. And the antibodies themselves can circulate in the fluids to find the antigens to mark them for destruction. And now, just like the other type, memory B cells are also produced. And this just shows how B cells can be activated. So here is an inactive B cell. Notice how it has a receptor. There are a few ways that it can be activated. It can be activated by the antigen itself, over here. And it can also be activated by a helper T cell. So both ways. Once the B cell is activated, it either makes clones of itself, so more B cells, in this case they're memory B cells that remember that specific antigen, or it changes into a plasma cell, and then you can see the red here, to make antibodies. This process in which the B cell, you can see it multiplying here, it's called clonal selection. Essentially, more clones of those exact same B cells are being made. Over here it says it proliferates and differentiates. All that means is proliferate, it makes more. It differentiates, it's either memory B cell or a plasma cell. Besides, like, we've talked about cell surface receptors before and how important they are to recognize self from non-self. One of the most very important, crucial aspects of the immune system is the ability of your cells to recognize self cells from non-self cells. And these MHC molecules on the surface of your immune cells make this possible. So like I said, they're on the surface and they flag self from non-self cells. And they're called MHC. And there's actually two different classes, that MHC1 and MHC2, that are possible on the surface. And they're very diverse. They vary from individual to individual. And in organ transplants, they not only try to match blood type, well, obviously they match blood type correctly, but they get as close as they can to the same MHC complex molecules on the cell surface, so your body doesn't reject that organ. Okay, so this shows a cytotoxic T cell that has been activated, so a CD8 cell, and how it works. So it goes and finds an infected body cell. So this cell in your body, we know it's supposed to be there because this green represents the MHC molecule, and it's holding an antigen. This activated cytotoxic T cell has been trained to recognize that specific antigen. Once they bind and essentially communicate, this cytotoxic T cell releases these chemicals, granulyzyme, perforin, that will essentially, like little throwing stars, to punch holes in that infecting body cell together with the granulyzyme to cause that cell to cytolysis, essentially burst open, become destroyed. This is just talking about that process, like I mentioned, clonal selection, and is just when a lymphocyte, a B cell or T cell, is stimulated to proliferate, so to make more and differentiate, either become a memory cell or something else. And it's triggered to do that by a specific antigen. And all those clones are identical to each other. Clone. Lymphocytes, they can go to produce effector cells. Effector cells are just simply the cells that do the work. So they're either active T cells, they're active cytotoxic T cells, or they become plasma cells. All of the effector cells, after essentially your body has won the battle to defeat the bad pathogen that time, they die. They go away. The cells that don't die right away are called the memory cells. They don't participate in that initial or first immune response, but if you do come in contact with that antigen again, like if I ever come in contact with chickenpox again, because I've already had it, my body has memory cells that can already recognize it and mount an immune response quickly. They proliferate quickly, differentiate quickly into more effectors and more memory cells that essentially fights off chickenpox before I even have it. Okay, so that is abbreviated version of the adaptive immune system. The main thing you need to focus on is the activation and the difference between B cells, T cells / cell, antibody mediated / cell mediated immunity.